Okay, so today we're going to talk about injection, and this is the number one with a bullet in terms of the vulnerability, severity, and I guess frequency. So that combined metric. So this is an important one, and it's not just one thing that you're looking for. It's any number of things that you can use injection for. So it's like a generic class of vulnerabilities. We're going to talk about maybe 3 or 4 different ways of doing injection, like the general classes. Today we're going to do 3 kinds of attacks: command injection, code injection, and SQL injection. In fact, this whole week will be an injection week. Because in the next class we'll do blind SQL injection. Because of the severity of this vulnerability, there are a lot of exercises that I'm going to have you do. And it's important, I haven't seen a lot of people sharing about the lab exercises. Either they're too easy and you don't need any help, or no one is asking for help when they need it. The Slack channel is meant for you to help each other out with the lab exercises if you're running into issues. It's the homeworks that I want people to sort of be able to do on their own. So this week, there's a lot of lab exercises. So if you're getting stuck, get help quickly to get unstuck. Yes?
Wait, when you say homework, do you mean the homework site?
Yes.
Like additional stuff?
The homework site and the programs. So the CS495 site, those are individual. I don't really want people giving a lot of help on those things. But the labs that are prepping you to do the homework, that's fair game. You can exchange ideas and you can do more detailed debugging for each other. And that helps people out in the long run. So that's what I wanted to point out. I mean, I've had instances of this class where there's been a lot more help given to each other. So feel free. The other thing I don't want you to help out each other out is the programming assignments. Those are also so individually done. Okay. So injection, the generic approach is to trick an application into executing commands or code embedded in data. So yet again, in security, as soon as you mix code with data, you got problems. And we've got a lot of these problems when it comes to the web, because we're always doing this. We don't have this clean separation between what we treat as code and what we treat as data. So you'll see that it's often injected into interpreters. So SQL, PHP, Python, JavaScript, Shell. These are all interpreters that will take commands and execute them on the target system. It can also be injected into documents. So XML or HTML. You can pull off injection attacks on. And this impact is severe. Typically, when you are allowed to do code or command injection, you have full ownership of that target resource. So account access, operating system access, and then in the case of SQL injection, you can dump the entire database and the schema. Okay, so the underlying problem is what we'll talk about a lot is breaking syntax. So what does this breaking syntax mean? So the idea is that you're going to inject data into some interpreter environment, and you're going to break out of that data sort of context and be able to inject code. So you're breaking syntax of the script to jump out into the execution of that script. Okay? So we'll talk about that, and this is the first part, to execute commands or to execute actual code. That's one way. Another way, which we'll also cover today, is breaking the syntax of a database statement. So a SQL statement, in order to inject more SQL code into that context. We will also talk about injecting into the syntax of an HTML page. This will come so the first 2 are more server-side vulnerabilities. Injecting into the context of a page, that's more of a client-side vulnerability, and that's what cross-site scripting is going to be. So we'll get to cross-site scripting in a couple of weeks, but we'll focus more on the server-side injection, those vulnerabilities first. And so the strategy, if you are an adversary and you're looking for ways to inject into the context of the running application, your strategy is to send a whole bunch of naughty characters at that web application to see what breaks. And so there is this, I think it's down here somewhere, there's a GitHub of naughty strings to send over the internet. That's what an adversary would do to figure out what code will actually break into the app. Okay, so we'll first start with command injection. So most web servers now are running Linux or Unix. And so there is web application code out there, and most web application frameworks will allow you, as a web app, to execute commands in the underlying operating system. Okay, it's just a facility. If you need access to files in the underlying system, then maybe you want a context that you can execute OS commands directly. And so in PHP, there are multiple ways to get commands in the context of the running machine. So there's the system call that is used within PHP, and then there is an eval call that you can use to evaluate some piece of code in the context of the operating system. In Python, os.system or eval. And these could be explicit evals or implicit ones. We'll talk about both of those. And if you have in your web apps any mechanism that will invoke eval or system on input that is coming from the user, then you have the ability, you have a vulnerability. You have the ability for that user to inject an operating system command. So you have to make sure that any input that you get from a user has to be sanitized against this before you send it to any of these two calls. So you're going to have to do some auditing in your code to make sure this doesn't happen. So some example exploitations. Once you are on that system, some things you would do, you would run an interactive shell, or perhaps even a reverse shell, which we'll talk about in a couple of slides. Or you'll just access sensitive files. So for example, if you have a shell, you can use cat or grep to get at etc password or any of these other files that you want. Okay, so here is an example command injection. So here's an innocuous PHP script. Very simple script. It says, the command I want to run in my web app is to echo somebody's name, right? So so this is going to be some route on my PHP server, and if the user specifies an HTTP parameter that's called name of his or her name, then this thing is just going to print out that name. So this is like the hello world of PHP. Except this has got a huge vulnerability in it. So typically when you click this, you would get foo back because the parameter you sent is foo. But this is not innocuous, because what happens if someone sends this as their name? What do you think will happen? Yeah, so that's actually going to not only do the echo, so it's going to do an echo of foo, but the semicolon, which I don't know if any of you have used, the semicolon in Unix separates multiple commands on a single line. So if you want to issue multiple Unix commands all in a row using a single line, you just separate those commands with semicolon. So that's basically what, so you'll get foo and then you'll get etc password below that. So you could try that on your own PHP server to verify. Well, actually, you'll be doing a lot of these things. So there's examples of these in the exercises. Okay, so the potential solution is just filter out all the semicolons in everyone's names. No one should have a semicolon in their name. So is this fixed? If I just filter all the semicolons out, am I done? And if not, people say, no, I'm not done. Why am I not done? There's more than one way to skin that cat. Yep, that's exactly it. So in Unix, there's all sorts of ways to get commands injected. So there's backticks, there's pipes, there's the logical operators in the shell. And if you are an advanced Unix command line person, there's way more ways to get command access out of this. And you have to filter every single one of these things. You have to know about every single one of these and then filter them. If you really want to do this correctly. And so there's a sequence. I don't have you do the Natus web security CTF, but there's a sequence in Natus where they go through all of these. And so this is one great way to learn how to execute commands in the Linux shell, like to see, oh, what does this do? And then you'll be able to sharpen your Unix skills by trying to break Unix. Yeah. Good thing you asked. Yeah, OWASP has. So OWASP is really good about remediation and libraries that will allow you to sanitize not just shell input. So it depends on your context. How, like the filtering that you want to apply on input is dependent upon the context in which you're using that input. And so there's HTML sanitization, there's command sanitization. And so for any of these, when we talk about remediations, I'll hopefully have a cheat sheet link. OWASP has these cheat sheets that say, if you are trying to protect against this particular threat model on this particular context, this is what you do. And so just being aware of this will allow you to then search for what you need. There's too many for us to go through all of them, but just to make you aware that there are standard ways of doing the filtering that you want to have done. Okay, so I'm not going to go through all of these different Unix things and what they mean. It's just you can actually test these things out yourself in the Unix shell to say, oh wow, that's pretty cool, backticks, or dollar parentheses. I had no idea. Okay, so just to give you some examples of this showing up, here are these GPON fiber routers. So you might think the stuff you're deploying in your house has been vetted, but typically it hasn't been vetted. In fact, people are just borrowing code left and right from different places to put in their Internet of Things devices and shipping it out. They're not auditing what's going on in there. They're just saying, hey, it works. I'm going to send it to my customers or my users. And so that's what happened here. Everybody who had a GPON fiber router, which was what the ISPs in several of these countries, that's what they were shipping out. And of course, it had a command injection vulnerability. So now you have 1 million routers where you can go ahead and execute commands on because of this. And if you look at the exploit, this was a simple curl command that will basically exploit one of those routers. So if you look at this, you can see here, as part of the UI, you can specify a command to run. And in this case, you're going to specify the ping command to run. And then moreover, when the ping command runs, you can see in this injection, there are 2 modes of escaping out to do command injection. They use the backticks and the semicolon. So not only after you do the ping, you can basically jump into another command and have that run on the router as well. Okay, so that's one of them. The other interesting one, the ironic one, was this cybersecurity giant Komodo. So they must be able to get their security right. Turns out they didn't. They were relying, and this happens a lot in companies. Companies are acquiring other companies that are using software that hasn't been vetted. So even though your bread and butter is security, your processes underneath probably aren't secure. And so they were using a commercial off-the-shelf vBulletin instance, and this is a bulletin board, an internal bulletin board where you're able to post messages and see replies. Old school Slack, you can think of it. And so this is the exploit code for, and this is what they call a pre-auth exploit. So this means you don't need an account on the vulnerable system in order to get full access to it. These are really severe because there are exploits where post-auth you can exploit the thing, but that means that you have an account on that system already. That's harder for an adversary because the adversary has to have an account created. When it says pre-auth, it means that if it's reachable on the internet, I can get complete ownership of that. So that's basically what this was. And they were running this and they hadn't updated it. And so if you look, this one had a widget configuration route. And as part of this configuration route, and you can see this is a widget implemented in PHP, you were able to set the code of this widget. And so somebody is setting the code to be a shell exec, which is the PHP way. I didn't list it in the previous one. Shell exec is another way for PHP to get on to the operating system and run a command. So that's what this exploit was. And you can see it's like a simple Python script that gets you the full ownership of that bulletin board system. And so typically, this is bad enough, but typically what would happen was you would exploit this bulletin board, and then you'd be like, well, what can this thing reach that I wasn't allowed to reach before? And this is what they call lateral movement. Once you get this exploit into an organization, then you can go from there to scan for other vulnerable things that the organization might run, and then hopefully Komodo doesn't have anything too important on their back end that needed protecting. Okay, so the next class of injection is code injection. It's a little bit different. We're going to talk about two ways of doing code injection. I'm going to do the harder way first. The harder way, it's similar to command injection, but instead of injecting into the shell and executing an operating system command, you're injecting into the script's source code directly. So how is this going to happen? So it's going to happen thusly. So here is the pattern in code that might be vulnerable. So you have some code, and we'll say it's PHP code, and it's got a separator between the PHP code and any user input that it might be getting from the request. And then to delineate the user input from the rest of the code, they'll use a separator. And typically it'll be a string separator. So in PHP, there are multiple different string separators. So it could be the single quote, it could be the double quote, whatever separator you're using. That's why it's abstracted out, because it could be different. And then that's followed by other parts of the PHP script. So what's going to happen is that you want to inject user input to break the syntax of this thing. Okay, so you do this by injecting a separator. And so you don't know what separator is going to work a priori, but you're going to fuzz it. You're going to fuzz it with the typical things that might break syntax. And then you're going to look to see if that thing generates an error. Okay. So here's what you would do. You would inject a separator to break the syntax. Then you would inject the malicious code. And this malicious code would be code that is compatible with the code that the application is written in. So if you're injecting into a PHP script, the malicious code would be PHP. Okay? And then in order to fix the script, you just broke its syntax. So now you have the separators don't pair up anymore. You would, at the end of this, inject another separator in order to fix the syntax of the target script. Okay, the other thing you could do, if you're too lazy to fix the syntax of the thing you broke, you can inject a comment character in the context of the vulnerable script. And that will comment out the rest of that code line. Okay, now if that breaks the whole script, then that's not an approach you should probably take, but it's one way to actually detect code injection is to start injecting the comment character and seeing what breaks in the application. So that's another thing to point out. Okay, when you inject the comment, so here's the case where you patched it up. So you inject a separator, malicious code, and you inject another separator, and that goes back to the legitimate code with your malicious code executed. If you inject the comment, then all you need to do is break syntax, run your malicious code, and then at the very end of it, insert the comment character, and then the rest of the separator and the code in that line don't get executed anymore. They get removed from the execution of the script. Okay, so as I said earlier, the separator is dependent on the context of the injection. So is it HTML? Is it SQL? Is it PHP? And it's also how the programmer has delineated the separator. So it could have been backticks, regular quotes, double quotes. And it's really important when you're doing these injection attacks, just because one separator worked to break one app doesn't mean it's going to work on another app. Every app you're trying to break is a completely new set of rules. And I want you, because I think a lot of people are like, hey, this worked on the previous CTF level, I'm going to try it again. I was like, it doesn't work. And then what are you going to do then? Well, what you're going to do is you're going to try a whole bunch of different separators, because you don't, unless you actually have the source code, you're stuck with guessing what's being used. Okay. The other thing is that the comment character that you inject is also dependent on the context of the script that's running. So typically, we'll talk about dash, dash, and pound, but The pound is for shell scripts. That typically will comment out shell scripts. The double slash is for like a C++ style a program. /*/ for C style comments. Any number of these things can be used to comment out code. So that is inline injection. So you would inject a huge list of these things and see what breaks that program. That would almost be the first thing that you would do when you come up to a CTF level that might be injectable. You just start throwing a bunch of characters at it and see what happens. Okay, so this is the GitHub of naughty strings if you need some ideas and you're stuck. There are some strategies for you to detect code injection in line. And these are, the ones I'm going to show you are PHP related because the only code injection levels I'm going to have you do are PHP injection ones. One strategy is to inject a comment /* in an input field and then put a random number in there and then do //. Now, if that random number doesn't appear anywhere, then you know it got executed in PHP because PHP will treat that as a comment and not execute that. So that's one strategy you can use. If you inject a comment and the program errors out, then you know you have been able to change the syntax of that target program that's running. You can inject string concatenation to break and reform syntax. And this is PHP specific. So you know the dot operator is string concatenation. So if you try and break syntax and then do a string concatenation of a bunch of substrings of hacker, and then in the output of the program, you see hacker reformed as a single string, you know that that string got executed as code because it will use the native concatenation of PHP to reform that string into hacker. Okay, you can also do a sleep injection. So if I inject a call to the native sleep, and this will work for both command and code injection. In fact, one of your exercises, I think it's the port swigger one, the third port swigger exercise I'm going to have you do. You inject a sleep, and if the thing sleeps that long before giving you a response, you executed some code on that target. Okay, so then you know it's vulnerable to other kinds of injection. Okay, and you could actually. So you can inject this command, not just in regular requests. In your profile, for example, you could say in your description, I like to sleep 10. And then when you load your profile, if it sleeps 10 to load your profile, then you're like, oh, it must be taking my profile information and somehow getting into the context of the running web app. And then you can actually, and this is called a second order injection, and you'll have one of those levels in the Web for Pen Tester, where it's actually a second order injection, where the thing that is reading the user profile is the thing that's getting evaled. So I just wanted to mention that. So I mentioned there are two ways that we're going to talk about. The easier way of doing code injection is via file upload. And so you already did this in your Web for Pen Tester one, where you're uploading PHP scripts. So if you have any application, any web application that is allowing puts or files to be uploaded using posts, you have to make sure that those files can't be subsequently executed by anybody. Because if you allow execution of anything anyone uploads, well then someone can upload this file. And if you look at this file, so say I have an upload file, upload.php, and I upload this script. If you look at this script, this is a canonical web shell. What it does is it says if there is a command parameter in the request, what I'm going to do is I am going to get the command that the adversary wants to run in this request, and I'm just going to return the results of shell execution of that command. So if this file is sitting there, if you were allowing the upload of this particular file and giving it a route, then when someone accesses this route with the command parameter of ls, they'll get a directory listing as the response. Okay. Are there questions about any of this? So it's a fairly simple set of vulnerabilities, the command and code injection. Let's talk about prevention. So filtering is one way to prevent this. So removing anything that can be interpreted as code or commands, stripping that out of all of the user input before passing it to the app. And then there are these encoding libraries. So we referred to this earlier. There are ways of taking input, encoding it into something that's completely data, and then passing that to the interpreter. And that's the typical way. This is the generic pattern for getting rid of these injection vulnerabilities, is to make sure you understand what could be interpreted as code in the target, and then taking the user input and making sure you sanitize it in a way that it's all data on the other side. And there are libraries for all sorts of operating contexts on to transform the user input into something that could only be interpreted as data on the back end. So there's things for cross-site scripting, there's things for HTML and JavaScript. There's all sorts of different filters for this. Okay. Another thing you can do is lower privilege levels of everything that's running. So you can run the web server with reduced privilege levels on Unix or on Linux. It's using www-data, so it's a non-privileged account that typically runs the web server. You could run the web server in a sandbox of sorts. So initially, web servers ran with a system called change root or BSD jails. And what this does is when you invoke change root or a jail on the web server, you specify a directory where the web server is not allowed to access anything outside of that directory. It confines the application into running that subdirectory. And then accesses outside of that directory will get denied. So that's just at the file system level, and that's all fine and good, but you can still run a shell, right? And so what Linux seccomp is a way of saying, you know what, for this web server, all it needs is this subset of system calls. So it should not use exec, for example. So if you remember, you all took operating systems, the fork and exec. There should never be an exec that this web server can run. And the seccomp filters are a way of specifying the system calls that web server has access to. And so if you really don't want that web server to run a shell command, you just get rid of exec. Okay. Another thing you can do is run everything in a container. And what containers do is it isolates the operating system that the server is running on. So it's like a virtual operating system. So you have the native operating system that supports a bunch of virtual operating systems. It separates the virtual operating systems from each other, and it separates the virtual operating system from the real operating system that's running it. So if someone jailbreaks one of the containers, won't be able to get outside of that container environment. So that's one way. Or if you want to do this at the machine level, you can run a virtual machine and completely isolate the machine that the web server is running on using VMs. Okay, so I'm going to briefly go over the labs and homework for command and code injection. I'm going to have you do the operating system command injection labs on Portswigger. So you're going to be doing the delay one. You're going to be doing several other, like the first four. There's actually more. I think there's actually more than that, but I'm just going to have you do the first four to get a feel for this. There's also the Web for Pentester 1 command injection levels. And these are more about filter bypass. The Portswigger ones are more about different techniques to exfiltrate and to actually do the injection. The Web for Pentester ones are about filter bypass. And then finally, Web for Pentester 2 has some code injection ones where you're bypassing the PHP stuff to execute PHP scripts. Okay. So with that is command and code injection. Do I have any questions about this? All right. So yep.
So, if I have to secure my operating system or my application, then if I run it into a VM, is that the best solution? One of the best solutions that I can use?
It's a trade-off between performance and security and what you're trying to protect and what you value most. So that's why all of these different things exist. So sometimes, virtual machines are pretty high overhead. Like you can only run on a real machine, you can only run maybe like, it depends on how much memory is in there, but like I have 6 gigs on my computer, I'm only running like maybe two VMs or 3 VMs because you need like a couple gigs of memory for each one of those. If you need the highest level of security, and I'm running some insecure stuff, so I want that in a VM. I don't want that stuff to break out, but I can only run 2 or 3 of them. If you need performance, well then containers might be the thing because when you're running a container, you can get these things down to hundreds of megabytes rather than a couple gigs. You can run, sometimes I run like 5 or 6 containers and there's enough memory in there because it's sharing the underlying operating system. With a virtual machine, you get no sharing, right? Like it's a complete stack. With a container, you're actually sharing the underlying operating system library, so you're not replicating all of that code and you're not replicating in memory all of that state. So then you can run more, but if there's some kind of bug in the container runtime, the thing that's running a bunch of the containers, then then you can get a jailbreak. So then performance versus security, that's typically what you would look for in terms of a trade-off. If containers are too high overhead, then maybe you just want a jail, right? Like the change root or, so there's no one best way, I would say. It definitely would depend on your operating parameters in terms of security versus performance. If you're a bank, I'd probably do a VM. If you're running a bulletin board, I'll run that in a container. That would be the other thing. Are there any other questions? But yeah, these are interesting things to think about, at least, operationally. Okay, that is